Hello everyone, it's me Rohan Benjkar, and in this video I'll be dealing with linear programming through simplex method and I'll apply the big M method. The big M method is generally applied while solving the minimization problem in simplex. So in order to use the big M method, there is the example of minimum cost. That is minimum cost equals to 0.85x plus 0.4y, where y denotes the units of food B, whereas x denotes the units of food A. Subject to constraints 2x plus y greater or equal to 8, 6x plus y greater or equal to 12, x plus 3y greater or equal to 9, x comma y greater than 0. These information has been jotted down from the question itself, and since the sign is greater or equal to, I will be introducing the surplus variables, and since I am using the big M method, I will be introducing the very large numbers v1, v2 and v3, and I also introduce the surplus variables since there is a sign of greater or equal to s1, s2 and s3 to our system. The standard form of primal LPP is minimum cost equals to 0.85x plus 0.4y plus 0 times s1 plus 0 times s2 plus 0 times s3 plus 10,000 bracket v1 plus v2 plus v3. For simplicity, I have assumed the coefficient of v as 10,000, but in many textbooks we see as m, and m is actually the standard form of using the coefficient of very large numbers, since the name itself suggests big M method. And subject to constraints 2x plus y minus s1, this is surplus variable and must be deducted, plus 0 times s2 plus 0 s3 plus v1 plus v2 times 0 plus v3 times 0 equals to 8. Previously our sign was greater or equal to, and it has been converted to the equal to sign. That is, previously it was in the form of inequality, while the inequality has been changed into the equation by introducing the big M and the surplus variable. Similarly, for the second and third constraints, that is minus s2 plus v2 minus s3 plus v3, and sign has been changed to equal to, and x comma y comma s1 s2 s3 v1 v2 v3 all are greater or equal to 0. Initial simplex table. The simplex table has been filled from the information from the standard LPP. Here Cj equals to coefficient of the objective function 0.85, 0.4, 0, 0, 0, 10,000, 10,000, 10,000. In place 10,000 we can see m, m, m and m, and bb equals to basic variable, cb equals to coefficient of basic variable. In our case, very large numbers are the basic variable, that is b1, b2 and b3, and cb refers to the respective coefficient, and zj is obtained by multiplying 10,000 into 2 plus 10,000 into 6 plus 10,000 into 1, and adding their results will get 90,000. Similarly, for the second 50,000, third minus 10,000 and so on. And the most important row is Cj minus Zj row, and this row determines which is our pivot column, and the least number in the last row determines the pivot column, that is minus 8 point minus 8999.2 is the least number, and for the minimization problem the least number is itself the pivot column, that is the x2. x2 is the pivot column, that is x2, that is the column in the orange color is the pivot column and with the least value. And similarly for the pivot row we must find out the mini ratio, and to find out the mini ratio we must divide the RHS by the values of the pivot column, that is 2, 6 and 1, that is dividing 8 by 2, 12 by 6 and 9 by 1, we'll get 4, 2 and 9. And the least in the mini ratio is the pivot row, that is second row is the pivot row which is in the orange color, and 6 is the pivot element, that is the intersection between the pivot column and the pivot row, and x is the entering variable and v2 is the departing variable, that is x comes in place of v2, and the coefficient also gets changed from 0.8 from 10,000 to 0.85. The coefficient also gets changed. And logic in simplex में प्रयोग हुने logic चाहिँ based on the row operation, that is pivot element equals to 6 at r2 so making it 1. हामीले यो r2 लाई चाहिँ 1 बनाउँछौं because our intention is to make 6 1 and 6 is in the r2, so the row operation is r2 tends to 1 by 6 times r2. हामीले r2 whole r2 लाई नै हामीले 1 by 6 ले multiply गर्छौं because our intention is to make the r2 1, that is make our pivot element 1 equals to 1, and with the help of the pivot element we will make the other elements of the pivot column 0, that is c1 को हाम्रो other element लाई हामीले 1 बनाएको pivot element को help ले 0 बनाउँछौं. So in order to make it 0 we will use the row operations in r1 and r3 such that r1 tends to r1 minus 2 r2 and r3 tends to r3 minus r2. अब हामीले simplex 2 मा this x will arrive here and its coefficient will arrive here. पहिला v2 थियो, v2 लाई रिप्लेस गरेर x आयो र v2 को coefficient is replaced by the coefficient of x2, and हामीले pivot element लाई 1 बनायो र 1 को help ले 0 बनायो and this 0. हामीले जुन अघि row operation r1 र r3 को माध्यमबाट बुझिसक्यौं र फेरि पनि हामीले त्यही प्रोसेस फलो गर्छौं. We will see the last row. हामी लास्ट रो हेर्छौं ल लास्ट रो को मोस्ट नेगेटिभ नम्बर भएको column is the pivot column, and we will find the mini ratio in the same process, that is RHS divided by the pivot column elements. pivot column मा भएको element हरुले चाहिँ respective RHS को बाट लाई डिवाइड गर्छौं, that is 4 divided by 0.6667, 2 divided by 0.1667, 7 divided by 2.833 र मिनी रेशियो मिनिमम भएको रो लाई हामी पाइभट रो भन्छौं, that is 2.833 is our pivot element र यसलाई हामी 1 बनाउँछौं, and with the help of this we will make these two 0, and for its we will see the row operation below, that is r3 tends to 1 by 2.83333 times R3 R3 लाई होल रोलाई हामीले 1 by 2.833 ले डिभाइड गर्छौं वा इन्टु मल्टिप्लाई गर्छौं R1 tends to R1 minus 0.6667 into R3 and R2 tends to R2 minus 0.16667 into R3. By applying these row operations, we will solve the problem. And in the simplex table 3, we can see that we have made the pivot element 1 and other two elements of that column 0, and y y has replaced v3 and its column and its coefficient has replaced the coefficient of v2, which was initially 10,000, and the same process is followed. The last row is observed and we will observe its least value, and which is pivot column, and we will find the mini ratio, and the least mini ratio determines the pivot row and its pivot element. We will make this 1, and with the help of this we will make these two 0, and the row operation for it is R1 tends to 1 by 0.299411 times R1, R2 tends to R2 plus 0.17647 times R1, R3 tends to R3 minus 0.58824 times R1. So यहाँ चाहिँ अब अहिलेको pivot element has been turned into 1, and with the help of this 1 we have made these two 0. S2 has occupied the place of V1, previously V1, and the coefficient of S2 has occupied the space of the coefficient of V1, previously 10,000, now 0. And again we will see the last row and the least negative number determines the pivot column, and similarly the mini ratio is calculated and the least mini ratio determines the pivot row, and the pivot element is obtained at 0.8, and we'll make this 1, that is R1 tends to 1 by 8 times R1, so this is 1, and with the help of this we'll make these two 0. For that we will take a row operation in R2 such that R2 tends to R2 minus 0.2 into R1, R3 tends to R3 plus 0.4 into R1 in the row 3, and by calculating this we will finally stumble to the final simplex table, that is table number 5, and the table number 5 we can observe that the last row is free of negative numbers, so we have found the optimal solution, and the optimal solution is at 3.25, that is since Cz minus Zz is free of negative numbers, the optimal solution is minimum cost equals to 3.25 at x comma y comma x3 equals to 1 comma 6 comma 10, and we can observe that this value, the 3.25, is the optimal value, and while solving the problem through bigger method this value comes on decreasing and decreasing, and finally at optimal point it will be the minimum, and it is our answer. Thank you.